we are going to find the radius of convergence and also the interval convergence of this power series. Okay, let's get to work. For the radius of convergence, it's not so bad because I showed you guys the formula for that already, right? So here we go. R is just going to be, we take the limit as n goes to infinity, and we are going to look at the Cn, which is the coefficient right here. And we do Cn over Cn plus 1 inside of an absolute value. And also, we have to pay attention to the coefficient of n right here in the power. Here we have 2. So, we are going to look at this limit and then take the square root, namely the second root. Okay, so that's the setup, and now let's just go ahead and get to work. Right here, we will have the square root, and then we have the limit as n goes to infinity. Cn is just that, so let's go ahead and put down n over 4 to the n, and then over Cn plus 1, which is just the reciprocal of Cn plus 1. So I'm going to put this down first with the n plus 1 here, and likewise I'll put that down on the bottom with n plus 1 here. And the absolute value doesn't matter because everything's positive inside, so that's good. And we see 4 to the n plus 1 can be written as 4 to the n times 4 to the first, and this and that cancel. Nice. And then as n goes to infinity, we just care about n, and then we just care about n right here. The plus 1 doesn't matter. So just work out the limit real quick. You will get square root, and everything inside is 4. And of course, take the square root of that is just 2. So there we have it. R is just nicely equal to 2. Now, take a look right here. This is the power series. In order to find out the interval of the convergence, not only we need to know the radius of convergence, but also the center. Here is the center. We have x minus a. A is 3, so a is equal to 3. This means the following. We have the number line, and the 3 is right here. And of course, the radius means that we can go to the left and go to the right. So if you move to the left 2 times, we get 1. And if you move it to the right twice, you get 5. Okay, so again, 2 this way and then 2 this way. Minus 2 and plus 2 pretty much. And you might be wondering, why is this called the radius? Because we are only going left and right. The reason is because this is one-dimensional. Later on, if you ever take a complex analysis course, you will see that when we are talking about a two-dimensional case, like x and y plane, it is really a circle. That's why it's the radius of convergence. But anyway, we do not know what will happen when x is equal to 1. We do not know what will happen when x is equal to 5. So we must test it out. So here we go. We are going to check. When x is equal to 1, let's just go ahead and put a 1 in here, and we will get the series as n goes from 1 to infinity, n over 4 to the n times negative, so let me show you guys the work, 1 minus 3, and then to the 2n's power. Inside here we get negative 2. So here this is the series as n goes from 1 to infinity, n over 4 to the n, and then we have the negative 2 raised to the 2n's power. But for this right here, what we can do is we can actually do the second power first and then the n's power. So this right here, it's a negative 2. And then let's do the second power, and then let's do the n's power. So in fact, this right here is the series as n goes from 1 to infinity, and we have n over 4 to the n. This is also 4 to the n. And as you can see, this and that cancel. Have a look. This is just the sum of all the natural numbers. N goes from 1 to infinity of n. So it's just 1 plus 2 plus 3 plus da 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 and so on, right? So of course this right here diverges. Yeah, because you can use the test for divergence if you like, because this right here does not go to 0. Alright? Now the second case is that we are going to check when x is equal to 5. Alright, so pretty much do the same thing. Plugging 5 into the x, we are getting the series as n goes from 1 to infinity, n over 4 to the n, and then plugging 5 into the x, and then minus 3, and then to the 2n power. Okay, this right here, it's the series as n goes from 1 to infinity, n over 4 to the n. This is 2. And then we are going to do the same thing, raised to the second power, and then raised to the nth power. And in fact, we have the same situation. N goes from 1 to infinity, n over 4 to the n. And this is just 4 to the n as well. This and that cancel, and we just get the sum of the series, right, of n. And again, this right here, diverges. Yeah, again, by test for divergence. So we will come back here and say, we are not going to include 1. We are not going to include 5. So finally, I will just write it down right here for you guys. R is equal to 2, and then the interval of convergence goes from 1 to 5, but we are not including the endpoints. So 1 and 5, not including 1, not including 5. And here we have it. That's the answer for that. Hopefully this helps. If you guys need to see more videos for Calculus 2, then just make sure you subscribe for future videos. That's it.